Hi everyone. In today's video, I will be going over the Unit 1 test review. So, in this first section, 1 through 6, we are asked which of the following are true statements. And then just a reminder, we do not distribute with an absolute value. So anytime you see a number or even a negative outside an absolute value, you will never distribute inside of it. That goes for the entire unit. All right, let's just go through these. Number 1. 4 plus the absolute value of -1 equals 3. So let's work with the absolute value first. The absolute of a negative is still positive. So absolute value of -1 is just 1. So this is 4 plus 1 equals 3. And 4 plus 1 is 5. And hopefully we all agree that 5 does not equal 3. This is a false statement. So this one is not true. Number 2, 18 minus the absolute value of 20 equals -2. Absolute value of 20 is just 20. So it's still going to be 20. Bring down everything else. 18 minus 20 equals -2. Now this time the negative was outside the absolute value, so it didn't get changed in this problem like it did in number 1. 18 minus 20 is -2. So that is a true statement. -2 is equal to itself. Number 3. Absolute value of 6 minus 8 times -1, still inside the absolute value, equals 2. So this is multiplication here. This is -8 times -1. So -8 times -1 is +8. So this becomes 6 plus 8, still inside the absolute value, equals 2. So again, I just multiplied these together, -8 times -1, and got +8. 6 plus 8 is 14, still inside of the absolute value, equals 2. Absolute value of 14, it's still going to be +14, nothing changed there. And clearly 14 does not equal 2, so this is a false statement. Number 4, negative absolute value of -9 equals 9. So let's do the absolute value first. Absolute value of a negative is still positive. So absolute value of -9 becomes +9. Now I'm going to put this in parentheses because this minus outside still comes down in front of the +9. And then last step, I'm going to drop these parentheses. So this is still -9. So the absolute value became a +9, but that negative on the outside made sure it didn't make a difference that there was an absolute value here. This minus outside still ensured that this was a -9 by the end of it. And clearly -9 is not equal to +9. So this is also a false statement. Number 5. Absolute value of 9 plus the absolute value of -7 equals 2. Absolute value of 9 is still going to be 9 plus absolute value of -7. It's going to turn it into a +7. 9 plus 7 is 16. And 16 is clearly not equal to 2. So this is a false statement. Lastly, number 6. 7 minus absolute value of -8 equals -1. So again, I'm going to work with the absolute value first. Absolute value of a negative is still a positive, so this just becomes 8. And for emphasis, I'm going to put parentheses around that. I'm going to bring down everything else. 7 minus equals -1. 7 minus 8 is -1. And -1 is equal to itself. So this is also a true statement. So we had 2 true and the rest were false. Next, solve the following absolute value equations. So here we have our full-blown equations with absolute values in it. I'm going to write out the steps that we're going to follow on every single problem so that we can keep them handy. Okay, so our first step is isolate the absolute value. Again, isolate just means get it by itself. Once we're there, we are going to write two equations. You'll have the positive equation and the negative equation. So you'll have those two. After that, you will just solve. And then a lot of students like to skip step 4, but on a couple of these that I'm about to do, this step is going to make all the difference in my answer. You are going to check the answers that you get. Also for this part, it would probably be helpful to have a calculator handy. I'm going to use one a couple times, so I recommend you having one handy. All right, let's go through the steps. Step 1, isolate the absolute value. So it really helps to identify which part we need to get by itself. So in number 7 here, our absolute value of x plus 12 is right here. So the whole problem, negative 4 times the absolute value equals negative 36. Now, some students are going to see this negative 36 on the right side and right off the bat write no solution and go on with their life. This is wrong. You cannot say no solution until you have at least done step 1. No matter what type of problem you have, you will always do the first step. So we need to isolate first before we can make any decisions. So to get it by itself, I need to get rid of this negative 4. Remember, this negative 4 is attached to the absolute value by multiplication. This is like negative 4 times this. So I'm not going to plus 4 to get rid of it. Again, if this is multiplication, to get rid of it, I'm going to have to divide by negative 4 on both sides. So the negative 4's cancel over here. Bring down the absolute value of x plus 12 equals negative 36 divided by negative 4 becomes a positive 9. Now that our absolute value is isolated, we can make a decision on what to do from here. And now we see that the number on the right side is no longer negative. So this is not a no solution problem. Step 1 is complete. Step 2, write two equations. So I have the positive equation and the negative equation. The positive equation is what I have right here, just no absolute value. X plus 12 equals 9. And the negative equation, it starts off the same. X plus 12 equals, and then I change the 9, I change its sign, so it's going to become a negative 9. So that was step 2. Step 3, solve. I'm going to solve both of these. This will only take a moment. I've got a plus 12, so I'm just going to minus 12 on both sides. X equals 9 minus 12, that is negative 3. I'm going to repeat that over here. Minus 12. X equals negative 9 minus 12 is negative 21. That was step 3. Don't forget about step 4, check. So we check with the equation we had right before the split. You can check with the original, but that's going to have a little bit more work. So I always go for this one. So for the check, I'm going to use the equation absolute value of x plus 12 equals 9. Make sure you use the equation that has an absolute value in it. I see students always checking these with these equations. It's really bad when you check with the one on the right because that is not going to work for what we need. So we need to make sure that our answers still work when we have the absolute value included because we got these answers by dropping the absolute value. So make sure you check with the correct equation. All right, I'm going to check underneath the answers. So I'm going to plug negative 3 in first. So I have negative 3 plus 12, absolute value, equals 9. Absolute value of negative 3 plus 12, negative 3 plus 12 is positive 9. Absolute value of 9 is 9. So 9 equals 9, that one works. So x equals negative 3 is an answer. Now I'm going to check negative 21. Again, I'm plugging it into this equation on the left. So x is negative 21. Negative 21 plus 12, absolute value, equals 9. Negative 21 plus 12 is negative 9. Still inside that absolute value, equals 9. Absolute value of negative 9 is a positive 9. It's going to become positive. So we got 9 equals 9 once again, so it worked. So x equals negative 21 also worked. So I've got two solutions here, negative 3 and negative 21. All right, let's repeat that 3 more times. Number 8, following the same steps. Isolate the absolute value first. So let's identify the absolute value. Our problem is 2 times the absolute value of 3x minus 2 plus 8 equals negative 6. So our equation divides through the equal sign, and we need to get to this part by itself. We have a couple things to move here. Again, some students are going to jump right in and say, oh, this is no solution because there's a negative 6 over here. You can make that decision after you're finished with the first step. So get it by itself, then decide. All right. When we're solving any equation, you always move the constant first. The number that's just off by itself. It's not attached to anything. So this 8 is what I'm going to move first. It's a plus 8, so I'm going to minus 8. 8's cancel. We get 2 times the absolute value of 3x minus 2 equals negative 6 minus 8. That's negative 14. Keep in mind, I'm trying to get this by itself. Next, I need to get rid of that 2. So, reminder, this is like 2 times the absolute value. It's attached to it. So to get rid of it, I need to divide by 2. I'm going to do that on both sides. So these 2's cancel out. I'm left with absolute value of 3x minus 2 equals negative 14 divided by 2 is negative 7. And finally, we have the absolute value by itself. Now notice that we have absolute value equals a negative number. When we have this automatically is no solution. So I'm going to clarify again. In this problem, we have absolute value equals negative number. That's the scenario we have. Absolute value on one side, negative number on the other. When we have that situation, then we just say no solution and we're done with the problem. So that's exactly what I'm going to do. So keep an eye out for those negatives. Next, number 9. Absolute value of 4x minus 1 equals 5x plus 37. Absolute value is right here. And then if I cut down the equal sign, we'll notice that we're already done with step 1. We have isolated the absolute value, or it's already been done for us. So now we can jump right into step 2, write 2 equations. So we're going to split into the positive and the negative. Positive, I'm going to write exactly what's up here, just no absolute value. So we have 4x minus 1 equals 5x plus 37. And then the negative, we're going to keep the absolute value part the same. 4x minus 1 equals. Now, you can think of it as taking the negative of this side, but if it's easier, just think that we are changing both signs here. So we're going to change all the signs on this side. So these are both positive, so this is going to become negative 5x minus 37. Once we have that, we can go ahead and start solving. So, In the equation on the left, I've got 2 x's. I'm going to move the smaller one, 4x, by subtracting it. So minus 4x on both sides. 4x's cancel. Negative 1 equals 5x minus 4x is just 1x plus 37. Trying to get the x by itself, so I'm going to move the 37 over here. This is a plus 37, so I will minus 37. 37's cancel. Negative 1 minus 37 is negative 38. Now keep in mind 1x is just x, so I'm going to drop the 1. And now you see I just have x equals negative 38. Now I'm going to repeat that over here. I've got a 4x and a negative 5x. I'm going to move the smaller one. This time that is the negative 5x. This is a minus 5x, so I'll plus 5x on both sides. 5x's cancel. 4x plus 5x is 9x minus 1 equals negative 37. Now I'm going to move the negative 1 over here to get the x by itself. This is a minus 1, so I'll plus 1. 1's cancel. Now I have 9x equals negative 37 plus 1 is negative 36. Lastly, I need to get rid of that 9, so I'll divide by 9 on both sides. Negative 36 divided by 9 is negative 4. So I'm done solving. The last thing I need to do is check. Now, if I'm going to be honest, these are the problems that you absolutely have to check if you're going to check any of them. When you have another x on the other side of the equation, not inside of the absolute value, this is when we're going to see that situation where one of these answers is going to work and the other one is going to fail. So it's really important that we actually check here. So I'm going to check. And I have to use the original equation. I wasn't able to change it. So I'm going to check using absolute value of 4x minus 1 equals 5x plus 37. I'm going to kind of do this separately in its own space. So first I'm going to check x equals negative 38. So I'm going to plug negative 38 into both x's. Absolute value of 4 times negative 38 minus 1, still inside the absolute value, equals 5 times negative 38 plus 37. Absolute value. 4 times negative 38, I'm going to put that into my calculator. That is negative 152 minus 1 equals 5 times negative 38. That's negative 190 plus 37. Negative 152 minus 1, that's negative 153 equals, I'm going to put this in my calculator. This is also negative 153. Absolute value of negative 153 is positive 153, but the right side is still negative. Now we can't have that be the case. So clearly we've got a positive equal to a negative. That does not work. So x equals negative 38 is actually not an answer. You wouldn't know that if you didn't check it. All right. Now let's check the same thing, but for x equals negative 4. So we have absolute value of 4 times negative 4 minus 1 inside the absolute value equals 5 times negative 4 plus 37. All right, 4 times negative 4, that's negative 16 minus 1 equals 5 times negative 4, that's negative 20 plus 37. Negative 16 minus 1, that's negative 17, still inside that absolute value, equals negative 20 plus 37, that is positive 17. Absolute value of negative 17 is still positive 17. So 17 does equal 17. This is a true statement. So x equals negative 38 did not work, so that's actually not an answer. But x equals negative 4 did work, so this is my answer. One more. Number 10. (5x plus 8 equals absolute value of 2x plus 4. They're trying to trip you up by putting the absolute value on the right side, so if that's a problem, just flip the equation. I'm going to do that. So we have absolute value of 2x plus 4 equals 5x plus 8. You are always able to flip an equation as long as you don't change anything when you do that. All right, so first step is to isolate the absolute value. As you can see, that's already been done for us, just like at number 9. So now we're going to write our two equations. The positive equation and the negative equation. 2x plus 4 equals 5x plus 8. And 2x plus 4 equals, the right side we change both signs. Negative 5x minus 8. And then we solve. We got 2x and 5x. I'm going to move the 2x. So minus 2x on both sides. 2x's cancel. 4 equals 3x plus 8. Now I'm going to move the 8. Minus 8 on both sides. 4 minus 8 is negative 4 equals 3x. Lastly, divide by 3 to get x by itself. 3's cancel. X equals negative 4/3. I'm going to repeat that to get this x by itself over here. I've got 2x and negative 5x. The smaller one is negative 5x, so I'm going to move that. This is a minus 5x, so I will plus 5x on both sides. (2x and 5x is 7x plus 4 equals negative 8. Next, I'm going to move the 4 over here. This is a plus 4, so I'm going to minus 4 to do that. So we get 7x equals negative 8 minus 4 is negative 12. And lastly, we divide by 7 to get the x by itself. 7's cancel. X equals negative 12 over 7. And lastly, we need to check. I am probably going to have to go onto a post-it note to finish the check just because I'm running out of some space. Okay. So for the check, once again, I'm going to use the original equation. I wasn't able to change anything about it. It doesn't matter which way you use it. I'm just going to use the one I rewrote. Absolute value of 2x plus 4 equals 5x plus 8. This is what I'm going to plug my x values back into to see if they're right. So first I'm going to check x equals negative 4/3. And I will definitely need the help of my calculator for this one. So we have absolute value of 2 times negative 4/3 plus 4 inside the absolute value equals 5 times negative 4/3 plus 8. Okay, I am going to be working with some not so nice decimals, but that's okay. So, 2 times negative 4/3, make sure you use parentheses in the calculator, just like how I wrote it. Negative 4, the calculator likes it when you use division for the fraction, so negative 4 divided by 3. And I'm actually just going to put this whole thing in here. Oh, let me delete that. Okay. All right. So inside of the absolute value, that gave me 1.333 repeating. So I'm just going to do 1.3 equals, and then I'm going to put the right side of my calculator, 5, and then parenthesis, negative 4 divided by 3, parenthesis, plus 8. That's also going to give me 1.3 repeating, so I'm just going to write 1.3. Lastly, the absolute value of 1.3 is 1.3, so I can drop the absolute value, and this answer worked. So, this one is good. X equals negative 4/3 is good. Now we have to check on x equals negative 12/7. Again, with my calculator's help. All right, so we are checking x equals negative 12/7. So we have absolute value of 2 times negative 12/7 plus 4 equals 5 times negative 12/7 plus 8. Once again, I'm just going to type all that into my calculator to make it easier. Okay, so first I have 2, parenthesis, negative 12 divided by 7, parenthesis, plus 4. And I'm just going to round that to 0.6. The 7 will bump the 5 up to a 6. So absolute value of 0.6 equals, now the right side, 5 parenthesis negative 12 divided by 7 parenthesis plus 8. And I'm just going to round that to negative 0.6. And then as you can see, absolute value of 0.6 is still 0.6. But I have a negative 0.6 on the other side of the equal sign. And that is not true. That does not work. So, x equals negative 12/7 actually is not an answer. And again, you would only know that if you checked. So, that one does not work. This is our only answer. All right. That is all for absolute value equations. So, actually, I'm sorry, I lied. There's one more, but it's a little different. Go on to the back, number 11. X equals 2 and x equals negative 3 is the solution for which equation? All this is saying is these are the answers to one of these equations. So instead of taking the time to solve both of these, we can just plug the answers in and see which ones they work for. So I'm basically going to just check. So we're just going in order. Let's start with A. Absolute value, I'm going to label this, absolute value of 2x plus 1 equals 5. Now, for this to be the answer, both of these have to work. So if one of them doesn't work, we're going to move on to the next option. So first, let's see if x equals 2 works. We have absolute value of 2 times 2 plus 1. Absolute value equals 5. 2 times 2 is 4, plus 1 equals 5. 4 plus 1 is 5. Still inside that absolute value. Absolute value of 5 is 5. Still positive. 5 equals 5, that works. All right, so if x equals negative 3 also works, then A is our answer. So now we got to check x equals negative 3. Absolute value of 2 times negative 3 plus 1 equals 5. 2 times negative 3 is negative 6 plus 1 equals 5. Negative 6 plus 1 is negative 5. Absolute value of negative 5, this turns that into a positive 5. And that also works. So both answers worked in the first equation. So A is the correct answer. So we got lucky that we just had to do it for the first equation and we didn't have to go through all three. All right, now we're done with absolute value equations. We're going to move on to inequalities. So inequalities have almost the same steps as equations. I'm going to write it out again. Step 1, isolate the absolute value. Step 2, write two equations, well, two inequalities. You're going to have the positive and the negative. Step 3, once again, you will solve. Oh, step 4. Now, the one big difference between the two is in inequalities, you're going to graph instead of check. Graphing's much quicker. So, before I jump in, this hint up here is to help you when you write the two inequalities. If you can't remember what that looks like, you can always look up here at the hint. So I'll demonstrate that on number 12. So, first step is to isolate the absolute value. Absolute value is right here. The symbol splits the equation. So it's already isolated from the get-go, so we don't have to do step 1. It's already done. Next is write two inequalities. So, we want to see which statement I have. I either have this one or this one. It's based on the sign. Now, hopefully you're able to recognize this is a greater than symbol, so I've got this one right here. So this is saying if I've got greater than, then I write this. So my absolute value is greater than what's ever on the other side, so 30. So for my first equation, which is the positive equation, all I do is drop the absolute value. Notice they look the same. So we have negative 6x is greater than 30. Or, that or is part of the answer, so make sure you write it. The left side still stays the same. Negative 6x. And just clarify, this is my negative equation. We flip the inequality sign, so it becomes less than, and then we change the sign of the 30, so it becomes negative 30. So you can always just follow the hint if you want, but this is very similar to the equations that we just did on the front side. When we make the negative equation, all we do is flip the inequality sign, and then we still make this number on the right side negative. So there's a lot of similarities there. After that, we're just going to solve. There's only one step here. I need to get rid of that negative 6. So I'm going to divide by negative 6 on both sides. Negatives cancel. We get x on the left side and then negative 5 on the right side. Now, they have already thrown this trick at you in the first problem. When you're solving an inequality and you divide by a negative on both sides, you're going to flip this sign. So now it's actually a less than sign. So that rule is if you multiply or divide by a negative on both sides, the sign flips. Or, I'm going to solve the equation on the right. Once again, I have a -6 here, so I'm going to divide by -6 on both sides. -6's cancel. X on the left, and then this becomes +5 on the right. Again, I divided by -6 on both sides, so this flips and becomes a greater than 5. Now this right here is the answer to the problem. I'm not done though, I still have to graph, so don't forget to do that. So, the graph is very straightforward. Got a -5 and 5. Make sure you put the numbers in the right order. Now, you can leave your graph like this. Typically, I'll put a 0 in the middle. It makes the negative versus positive part easier, but this is all you need. So, I'll put a 0 in the middle, but you don't have to put it if you don't want to. Next, we need to put dots on these. Since these are just less than and greater than, they don't have the equal to. We're going to do open dots. And then the -5, the inequality sign is pointing to the left. So we're going to draw it going this way. Imagine the inequality sign is the arrowhead. And then the 5, the inequality is pointing to the right. So it's going to go this way. And this is how my graph is supposed to look. This is an OR graph. They point away from each other. So this is just further means I probably did it correctly. All right, that's one. Let's do 3 more. Number 13. 7 times the absolute value of x plus 5 minus 17 is less than 32. So first thing we need to do is isolate the absolute value. As you can see, it's not isolated yet, so this is going to take a couple steps. First thing we do is move the constant, the minus 17, so I'm going to plus 17 on both sides. 17's cancel. So on the left, we have 7 times the absolute value of x plus 5 is less than 32 and 17. That's going to be 49. Again, I'm trying to get this by itself. This 7 on the front is attached by multiplication. So to get rid of it, I'm going to have to divide by 7 on both sides. 7's cancel. We get absolute value of x plus 5 is less than 49 divided by 7 is 7. Now I have the isolated absolute value. And now I can make 2 equations, the positive and the negative. Once again, if you want to follow the hint to make your equations, you can do so. This time you will follow this hint over here for the less than sign. However, I'm just going to do it from memory. So, the plus means I just dropped the absolute values. So we have x plus 5 is less than 7. And we need to figure out what goes in the middle here, what word. Remember, your options are and or. Well, I've just shown you this is the less than, so it's this one over here. So we use and. So this is and. You can also remember as less than means less than. This is an and statement. And then for the negative, the left side will stay the same, x plus 5. Flip this, so now it's a greater than sign. Change the 7 to -7. These are my 2 equations, and now I will solve. So first I just got to move the 5. This is a plus 5, so I'm going to minus 5 on both sides. 5's cancel. X is less than 2. And, again, minus 5 on both sides. 5's cancel. X is greater than -12. This is my answer. All that's left to do is graph it. So I've got 2 and -12, so I'll put a 0 in the middle. Negative goes on the left, So negative 12 goes over here. And then positive 2 goes on the right. And then again, no equal to here. So these are both going to have open dots. And then starting with the 2, the inequality points to the left. So I'm going to draw my arrow pointing to the left. For the negative 12, my inequality points to the right. So my arrow is going to point to the right. It doesn't matter which one overlaps which, just make sure that these are overlapping. And they're supposed to overlap because that's what an and graph looks like. All right, 2 more. Number 14. Absolute value of x minus 11 over 3 is greater than or equal to 5. Now, first goal is to get the absolute value by itself. Well, that over 3 is a little, it's just in the way. So let's get rid of it. So remember, this is like dividing by 3. So if I want to get rid of the 3, I'm going to do the opposite of divide by 3, which is multiply by 3 on both sides. So these 3's are going to cancel. And now I'm just left with the absolute value of x minus 11 is greater than or equal to 5 times 3 is 15. Absolute value is isolated. Now I can write 2 equations, the positive and the negative. Positive equation, x minus 11 is greater than or equal to 15. All I did was drop the absolute value. And then we need a word in the middle. This is greater than, great or than, so that's an or statement. Again, you can just look at the hint above. Greater than is an or statement. All right, and then minus the negative inequality. X minus 11, flip this to say less than or equal to, change the 15 to a negative 15. And now I solve both of these. Just one step to solve. This is a minus 11, so I'm going to plus 11 on both sides to move it. We have x is greater than or equal to 15 plus 11 is 26. Or, once again, plus 11 on both sides. X is less than or equal to negative 15 plus 11 is negative 4. So, this is my answer. And lastly, don't forget to graph. So I got 26 and negative 4, so 0 in the middle. The negative 4 will go on the left, and the positive 26 will go on the right. We have the or equal to on both signs, so I'm going to put solid dots this time. From here, the 26, the inequality points to the right, so I'm going to draw the arrow going to the right. And the negative 4 points to the left, so I'm going to draw the arrow pointing to the left. And this is what an OR graph should look like, so I've got a pretty good idea that I did this correctly. All right, number 15. Last one of these. First, we need to isolate the absolute value, which is right here. Negative 3 times the absolute value of 4x plus 2 is greater than or equal to 20. So, first thing I need to do, I'm going to move the constant, the 2. This is a plus 2, so I'm going to minus 2 on both sides. 2's cancel. Negative 3 times the absolute value of 4x plus 2 is greater than or equal to 20 minus 2 is 18. we are still not isolated yet. We need to get rid of that negative 3. So I'm going to divide by negative 3 on both sides. So you're going to cancel. Absolute value of 4x plus 2. And then 18 divided by negative 3 is negative 6. Now, notice I divided by a negative on both sides. This sign is going to flip. So, let's stop here for a moment. Notice, in this problem, I have absolute value is less than or equal to a negative number. Hopefully you caught this negative 6. It's negative. That's a problem. So, this is either a true or a false statement, always true or always false. An absolute value, which is always positive, can it be less than, the equal to really doesn't matter, but can it be less than or equal to a negative number? And remember, the absolute value is always positive. So an always positive number smaller than a negative number? I don't think so. So this is never true. So your final answer is no solution. And that's all we can do on that one. All right, next page. Evaluate the piecewise function at the specific values. So here is our piecewise function. We have g of x equals x plus 4 if x is less than negative 4. It's equal to 2x plus 5 if, remember this is like x is between those numbers, so it's between negative 4 and negative 1. Now we have the or equal to there, so we have to keep that in mind as well. If we put negative 4 or negative 1 in the middle, it would still be correct. And then lastly, g of x equals negative x plus 3 if x is bigger than negative 1. So we're going to go through these one by one. Once we get in a groove, these actually don't take much time at all. So, first thing we need to do, g of negative 5, we're trying to figure out what that is. This means that negative 5 is our x value. We need to figure out which of these our x goes into. So I'm just going to go through them until I find the right one. So, we're going to do the top one first. Negative 5 is less than negative 4. So you have to ask yourself, is this true or false? This is true. Negative 5 is less than negative 4. That's true. So we are going to use the top function, the one that goes with that. G of x equals x plus 4. So I'm going to plug the x in. G, we know x is negative 5. Equals, again, we know that x is negative 5 plus 4. G of negative 5 equals negative 5 plus 4 is negative 1. And the question was, we needed to find what g of negative 5 equaled. So if I'm going to add a little more clarity, we had to find what that was equal to. It's negative 1. So this is our answer, and we are done with that one. We're going to do that 5 more times. Number 17. G of negative 5 over 2. So again, all that means is that x is equal to negative 5 over 2. And I'm going to write that as a decimal. I think most of you are going to be more familiar with the decimal form. Negative 5 over 2 is negative 2.5. So let's use that instead. All right, let's see which of these negative 2.5 works for. So we're going to start with the top one. Negative 2.5 is less than negative 4. True or false? False. Negative 2.5 is not smaller than negative 4. It's bigger. So now we're going to go for the middle one. Negative 4 less than or equal to negative 2.5 less than or equal to negative 1. So is negative 2.5 in between negative 4 and negative 1? Yes, it is. This is the one we're looking for. So that means we're going to use the middle function, the one that goes with that. So use g of x equals 2x plus 5. So g of, we know x, it's negative 2.5, equals 2, again we know x, it's negative 2.5, 2 times negative 2.5 plus 5. G of negative 2.5 equals 2 times negative 2.5. You can use a calculator for that. It's negative 5 plus 5. And then lastly, g of negative 2.5 equals negative 5 plus 5 is actually 0. So 0 is our answer. Next one, number 18, g of 6. So again, that means x is 6. So I'm going to go through and plug 6 in to these three until I find the one I'm looking for. First one, 6 is less than negative 4. Hopefully you say that's false. 6 is clearly not less than that. It's going to be bigger than a negative number. Let's try the second one. Negative 4 is less than or equal to 6. Less than or equal to negative 1. So again, remember this just means 6 is between negative 4 and negative 1. That is a definite no. It's still positive, so it won't be between two negatives. So it's got to work in the last one. X is greater than negative 1. So again, is 6 greater than negative 1? Absolutely, it's going to be bigger than a negative number. So that means we're going to use the bottom function. So it worked in the last one, so we're going to use negative x plus 3. So use g of x equals negative x plus 3. So we have g of x is 6 equals negative. We know that x is 6 plus 3. G of 6 equals, this is negative 6 plus 3. G of 6 equals negative 6 plus 3 is negative 3. So g of 6 is negative 3. That's all they're asking for. Number 19, g of 0. Going to go through that process again. Let's see which of the three it fits into. So our x value is 0. So first we're going to test it. Is it less than negative 4? 0 less than negative 4. Hopefully you think not. It is not. Less than negative 4. It's bigger than negative 4. Next we have negative 4 less than or equal to 0. Less than or equal to negative 1. So again, this means 0 is between negative 4 and negative 1. No, it's not. It's bigger than both of these. So this still doesn't work. So now we're going to try the last one. X is greater than negative 1. So is 0 greater than negative 1? Absolutely it is. It's bigger than negative 1 by 1. So we're going to use the bottom function. Use g of x equals negative x plus 3, just like I did in the last problem. So we have g of our x is just 0 equals negative, once again, x is 0 plus 3. G of 0 equals, now there's no such thing as negative 0. 0 isn't positive or negative, it's considered neutral. So ignore the sign, it's just 0 plus 3. And 0 plus 3 is 3. So g of 0 is just 3. All right, only 2 to go. Number 20, g of negative 1. That means x is negative 1. So again, I'm going to run this test and see which one is true for negative 1. So we have negative 1 is less than negative 4. Is that true or false? Is negative 1 less than negative 4? No, it is not. It's bigger. Let's try the next one. Negative 4 less than or equal to negative 1 less than or equal to negative 1. Now this one is negative 1 between negative 4 and negative 1, and in this case, is it equal to either of these? It is equal to negative 1. So this one actually passes the middle test. So since it passed, and this takes up a little more room, so I'm going to drop down here. So we passed the middle one. So for the first time on this page, I'm going to use the middle function. Nope, this is the second time. I'm sorry, I lied. We're going to use the 2x plus 5. We did that in 17 as well. So use g of x equals 2x plus 5. So we have g of x is negative 1 equals 2. Again, x is negative 1, so 2 times negative 1 plus 5. G of negative 1 equals 2 times negative 1 is negative 2 plus 5. G of negative 1 equals negative 2 plus 5 is just positive 3. So g of negative 1 equals positive 3. One more of those. G of negative 12. So for our last one, x is negative 12. That's what this means. So I'm going to see which of the three it fits into. So we're going to start with the first one. Negative 12 is less than negative 4. Is negative 12 less than negative 4? Yes, quite a bit. So for the first time in a bit, we're going to use the top one. Past that one, so we're going to use the top function. So we're going to use g of x equals x plus 4. So g of the x is negative 12 equals, again, we know that x is negative 12 plus 4. G of negative 12 equals negative 12 plus 4 is negative 8. So that is my answer. All right, that's all for the piecewise functions. We've got one more page to look at. We're going to do these 4 graphs, and then we will be done with the video, with the study guide. Find the indicated values, y-intercept, and state the domain and range of each piecewise function. So we're going to start with 22 here. Y-intercept, we're looking for where it crosses the y-axis. So we're looking for at the y-axis where it crosses. Now I've got 2 dots on the y-axis. Remember, this one's a hole, so that means it doesn't count. So I'm going to ignore this one. The y-intercept is right here, and it looks like it's at -1. So the point, remember on the y-axis, so y is -1. So the x value here is 0. Make sure you write that down correctly. X is 0, y is -1. Domain and range. So for domain, remember domain is your x values, and it moves from left to right. So I'm going to look at the leftmost side of the graph. So the furthest left I can go on this graph is right here. Now I understand this arrow is pointing up, but it doesn't just point straight up, it's angled. So it's also going up and to the left, yeah? So it's pointing to -infinity. The left side of the x-axis is -infinity, and the right side is +infinity. If you ever forget, just think about what kind of numbers are over here. This is the negative side of the x-axis. So if it's going left, it's going to -infinity. So we're going to start our domain at -infinity, which always gets a parenthesis. From here, we're just going to follow the graph to the right and see what happens. And we want solid graph. That's what we always look for. So we got solid graph until we get to here, where we have the 2 points. Now, as long as one of them is filled in, we're good. So I can ignore the fact that there's a hole here, and I'm just going to carry on with the bottom graph and follow it. Solid graph, and then I hit this arrow over here. This arrow, yes, it's pointing up, but it's also going to the right. So it's going this way to +infinity. So my domain is actually -infinity to +infinity. And that's it for domain. Range. Range, remember, is your y values, and we go from bottom to top. We start at the bottom of the graph and we work our way up. So let's find the bottom of the graph here, the lowest point. That's going to be this point right here. Now this point is at -1 on the y-axis, -1 here, which that was also the y-intercept. So our range is going to start at -1. And then we're going to start down here. And this time we're going to go up. So when we get to this little split here, it looks concerning at first, but even though there's a hole here, there's a solid graph here. So again, I can just ignore the hole and just continue upward. This graph ends in an arrow. That's fine. We'll keep going just a little bit more. The graph, the highest point is this arrow up here. Now we discussed it was going left, but this time we're looking at up and down. So clearly it's going up. So it's going upward to +infinity. So just to clarify, on the y-axis, up is +infinity, down is -infinity. So we started at -1 and it kept going until it kept going to +infinity. So our range is -1, and this gets a bracket since it was a solid point. And then the infinity always gets a parenthesis. All right, f of 0. So we just looked at stuff like this on the other page just a moment ago. Remember, that 0 means x equals 0. So if x is 0, what is y? That's the question. So we're trying to make a point here. The point is 0, something. We need to figure out what that something is. So let's find where x is 0 on the graph. X is 0 right here. So we're going to go up and down until we hit a point. Right here. So when x is 0, the graph says that y is -1. So it's equal to -1, which actually was our y-intercept point. Okay, let's do that again for the 4, f of 4. This means x equals 4. So we need to find what y is. So x again is 4. We need to figure out what the y value is. So let's go to 4 on the x-axis. 1, 2, 3, 4. Here we are. Now again, we're going to go up and down until we hit the graph. We hit the graph right here. So what y value is that? 3. Yeah, 3. So when x is 4, y is 3. So f of 4 is equal to 3. So for these two, we're just finding points on the graph. You just have to know how to read it. This is telling you what the x value is. You have to find the y value. All right, we're going to repeat that 3 more times, and then we'll be completely done. Next graph. This one was clearly hand-drawn, so I do apologize if it's a little hard to read. Y-intercept, where does it cross the y-axis? Here's the y-axis. It crosses right here. And I always count the lines because they're a little different on this graph than they were on the last graph. So originally this looks like 3, but if you count 1, 2, 3, 4, this is a 4. So just be careful with that. So our y-intercept, y is 4, and remember x here is 0. So 0, 4 is our point. Domain. Domain, that's your x values, and we move from left to right when we're doing domain. And just to clarify, there are arrows on this graph. I think some of you might have been able to assume that. If it just cuts off, like it's missing, usually it's going to keep going. You just can't see it. Okay, so we're going to start on the left side of the graph. The leftmost part is this arrow right here. Yes, it's going down, but it's also going down and to the left side. So it's going this way to -infinity on the x-axis. So left to right, left is -infinity. So our domain starts at -infinity with a parenthesis always. And again, I can put the infinities where they go if it helps. -infinity on the left, positive on the right. Okay, so we're going left to right here. So we're starting here, and we're following the graph to the left, or sorry, to the right. We want solid graph like we have right now. We're going to stop here because this might cause an issue, but remember, the hole is not a problem if there's another solid point in its place. So I'm going to just go with this one and ignore this one. So I'm going to keep following it, and then I end at this arrow up here. So I'm going to stop here. This is the right side of the graph. Yes, this arrow is going upward, but it's also going to the right. It's like going at an angle. So this is moving this way towards positive infinity. So once again, our domain is actually -infinity to positive infinity. Range. Range, once again, these are the y values. We go from bottom to top. So we're going to start at the bottom of the graph and work our way up. So if I start at the bottom of the graph, the lowest part of the graph is down here. Again, where the arrow is. So a moment ago, we were looking at the fact that it was moving to the left, but now we're looking at up and down. Clearly, this is moving downward. So it's moving this way. Gosh, why did I draw that? I'm sorry. It's going this way to -infinity. So the arrow is going down to -infinity. So we're going to start our range at -infinity with a parenthesis always. Again, the bottom of the y-axis is -infinity. The top of the y-axis is positive infinity. Okay, so we're starting at the bottom and we're just working our way up. So we start down here and we follow the graph upward. Now this is a problem. The y values stop here, and here is 0. On the y-axis, it's 0. So we went from -infinity up to 0, and then it just decided to take a break. This is a hole here, so this is a parenthesis. But we're not done. There's still more graph up here. So I'm going to jump from this hole to this point. This point, again, I got to just count to make sure because these are kind of off. 1, 2, 3. So this is 3. So we're starting back up at 3. If you don't remember what goes here, just wait, leave a space. We're going to start back up at positive 3. There's a point there, so it's going to be a bracket. So we're starting back up at 3, and then I'm following the graph upward. And then I hit this arrow at the end. Now this time, yes, it's going to the right, but again, this arrow, is it going up or down? It's going up. So it also is moving this way to positive infinity. So we went from 3, and then it just kept going. 3 to positive infinity. Always gets a parenthesis. Now, last but not least, in the middle here, when you have a gap, a jump, I like to call it, it actually is called a jump discontinuity. You don't need to know that for this class, of course. You have to connect the two together. And we do that with a nice little symbol. I'm drawing it sideways here, but it's a U. Just a nice little U. U for union. It is uniting the two pieces together. So, when you have a jump, you have to unite them. Bring them back together. All right, 2 more questions. F of negative 3. Remember, that just means x is negative 3. So we have a point we're looking for. Negative 3 something. We need to figure out where does the graph hit negative 3 for the x. Where does it hit the y? So let's go to negative 3 on the x-axis. It's right here. And then we just go up and down until we hit the graph down here. So we've got negative 3 and then 1, 2. This is negative 2. So f of negative 3 is negative 2. I'm going to do that one more time. F of negative 1. So negative 1's right here. So, sorry, I got ahead of myself. That means x is negative 1. So my point is negative 1 something. So let's go back to the graph. Negative 1 is right here. So we're going to go up and down until I hit the graph. Now right here, remember this is a hole, so that doesn't count. It's not part of the graph. Up here, the solid point, that's what I want. So if x is negative 1, y is 3. So negative 1, 3 is this point right here. 2 more. Number 24. Also read the note. It says that each line on the x-axis and y-axis goes up by 2. So each of these notches is actually 2, not 1. Just pay attention to that. Okay. Y-intercept, where does it cross the y-axis? Right here. Now it's halfway between 0 and 2, so we're going to use that as a 1. Y is 1, x is 0. Domain, this is your x values. We move from left to right. So left to right, left is negative infinity, right is positive infinity. I'm going to find the leftmost part of the graph. That's right here. Now, this is, yes, it's pointing down, but it's at an angle. It's going to the left. So it is going this way to negative infinity. So we're starting our domain at negative infinity with a parenthesis always. And then we're just going to move along the graph to the right. So we're going to stop here real quick. We've got some differing points going on. Now these both go with 3 on the x-axis. We've got a hole, but we also got a point. So because of that point, I can ignore the hole and keep going. So to the right some more. And then we're going to stop because the graph stops here at this arrow. So here's the right end of the graph. So, yes, it's going down, but again, right now we're doing left and right. So is this arrow going to the left or to the right? It's pointing this way. It's going to the right. It's moving to the right slowly. So this arrow is going this way to positive infinity. Again, make sure you're paying attention to which direction you're looking at. Right now it's just left or right. I don't care that it's pointing down at this moment in time. Okay, range. It's your y values. We're going to move from the bottom to the top. So we start at the bottom of the graph and work our way up. For the y-axis, negative infinity is at the bottom, positive infinity is at the top. So we start at the bottom of the graph, and the lowest the graph goes is here and here with the arrows. Now the arrows are clearly pointing down. It doesn't matter which one I look at. They both do the same thing. So they're both going down to negative infinity. So my range starts at negative infinity with a parenthesis. So I started down here, and now I'm just going to move up and see how it goes. I'm going to move up, stop for a moment because of the hole. However, I do have a solid graph over here. So the hole is not a problem because I've got more graph over here to cover it. So again, we can ignore the hole and keep going. Keep going, and we're going to stop. This time it's at a point. This point right here is between, remember these are each 2, 6 and 8. So this point is 7. So we're going to stop at 7 this time. And there's no more graph after that. There's not an arrow, nothing. The graph just stops. Since it's a solid point, the 7 gets a bracket. And that's my range. All right, let's do the functional values real quick. F of negative 3. So that means x is negative 3. So we're looking for a point on the graph. We have negative 3 something. We need to figure out what the y value is. So, negative 3 on the x-axis. Again, remember these are each 2. So right here is negative 3. So I'm going to just sweep up and down until I hit the graph. Now I've got 2 points here. The hole does not count, so I'm going to go to the solid point instead. So this point right here is what I want. So the x is negative 3, and we've already talked about this. The y is 7. So the y value is 7, so it equals 7. Again, the number in parentheses is the x, and then the number that we write in on the other side of the equal sign is the y value. One more. F of 2 means x is 2. We need to find, again, what is the y value. So we have a point 2 comma something. The y value is going to go right here. So let's go look for 2. Reminder, these each go by 2. So this is 2 on the x-axis. And then we're going to go up and down until we hit the graph right here. And that's going to be halfway in between negative 2 and negative 4. So this right here is negative 3. So our point is 2, negative 3. So that's our y value for that one. All right, we've got one more graph and then we're done with the study guide. Number 25. One more time, we are looking for the y-intercept. The y-intercept is where it crosses the y-axis. So I'm going up and down the y-axis to see where the graph hits, and that's right here at negative 2. So our y-intercept, the y value is negative 2, the x value is just 0. Make sure you write that correctly. From here, we need to find the domain and range. So domain first. Domain is your x, left to right. So we're going to start on the left side of the graph. The left, like most left part of the graph is right here, this arrow. So this is where we're going to start. Now again, we're only concerned about left and right. So this is clearly going up, but is it going to the left or the right? It's angling to the left for sure. So it's going this way to negative infinity. At least it's heading this direction over time. Again, x-axis, negative infinity on the left, positive infinity on the right. So we're going to start at negative infinity. Always gets a parenthesis. Now we're going to go to the right and just see what happens. So I'm going to follow this graph to the right. We're going to stop here. Again, we've got that 2-point thing going on at -1. Now that's not a problem because one of them is a hole, but the other one is a solid point. So because that solid point is there, it cancels out. We can ignore the hole. Let's keep following the graph. Now it's down here. And then it stops at an arrow. So it stops right here. Now this arrow, we're looking at left or right. It is clearly going to the right, to positive infinity. So once again, this domain is negative infinity to positive infinity. You're going to be using that a lot in this class. So don't be surprised when that's your domain. Or your, sorry. Yeah, that's your domain. I said that correctly. All right. From here, range. Again, this is your y value. Y values, so you're going from the bottom to the top. So we need to find the very bottom of the graph, so it's going to be over here somewhere. The very bottom part is this arrow. Reminder, the bottom of the y-axis is negative infinity, and the top is positive infinity. So from here, we marked the bottom as being right here. Again, while this arrow is going to the right, is it moving up or down? It's clearly moving down. So it's going this way, down to negative infinity. So our range starts at negative infinity with a parenthesis. So we're going to start at the bottom. We're going to work our way up the graph. I'm going to stop here, and it's a hard stop because it's just a hole, so I've got to stop. So on the y-axis, now this looks like it's in the middle, so I'm going to go with that. This is between -1 and -2. So this is -1.5. We're just going to use that. So -1.5 is the stopping point right here. And it's a hole, so it gets a parenthesis, not a bracket. From here, we've got more graph. So I'm going to be here, and I'm going to jump up. The next number I jump up to on the y-axis is 3. So my next starting point is a 3. And there's a solid point here, so I'm going to put a bracket around it. So we're starting again at 3, and then we're going to continue up until we reach the top, which is this arrow. And clearly, this arrow is pointing up. So it's going up to positive infinity. So 3 to positive infinity is the rest of the domain, or sorry, the range. In a parenthesis, like always. Lastly, I left this space here. When you have a jump, any kind of jump in the graph, in your domain or your range, by the way, you're going to unite them with a union symbol. So, union for the two here. And then the range is done. Last two questions, f of -2, so that means x is -2. X equals -2. So we need to figure out what y is. So we're looking for a point, -2 something on the graph. So let's go to -2 on the x-axis. -2 is right here. So let's go up and down till we hit the graph. Right here. So here's the point with -2 is the x value, and our y value is 5. So the point is -2, 5. Yes. So when x is negative 2, y is 5. Lastly, f of 2. Very similar question, except x is positive 2. So again, we need to figure out what y is. So we're looking for the point 2 comma something. So we're going to go to the graph. 2 is right here on the x-axis. So we need to figure out if x is 2, what is y? So we're going to sweep up and down until we hit the graph right here. So when x is 2, y is negative 3. So there was our point, 2, negative 3. All right, everyone, that is all for this video. I'm sorry it was as long as it was, but I want to take my time, make sure I explained everything, so I hope you do at least get something out of that. Hopefully everything I've gone over has made sense, and hopefully I've answered any and all of your questions. Thank you for watching all the way through. If you have, I really do appreciate that. If you have any additional questions after watching this, feel free to go back, rewind, rewatch as many times as you need to. I recommend doing that first. And then if it still doesn't make sense, feel free to reach out to me either via email or come see me in person. Otherwise, I hope you all have a wonderful day. Bye.